base.
That's,
By the way, don't make this harder than what it needs to be. This would technically be a 1-1,
So 2-2, so.
which is a 45-45-90 triangle, so you just multiply by the root of 2 to get the hypotenuse, okay? So this is just square root of 2. Same thing on this one.
It's the same thing, except it's 2, so.
It's a 2 root of 2, I think. Okay, so that gives us the 1/2 and the 2 cancel out. The root of 2 times the root of 2 is just good old 2.
Damn.
So bam.
Geometry.
Geometry for the win.
That actually took a lot, that was a lot faster. But in
Yeah,
this
you
case-
still needed to know, all right, my 45 triangle, or use Pythagorean
I
theorem, or however you wanted to set it up. What did you use for Pythagorean, by the way?
I just know that that's 2-2 and that's 0-4, so I just did a,
You did,
I created my
you
own
did
triangle.
this triangle.
no. I created my own triangle between 0-2, 2-2, and 0-4. And then I just did,
Like this.
I made my own triangle. And made it
Gotcha.
through.
Works for me. You did it 2 by 2 and then did the Pythagorean, I got you.
Yeah.
Okay, or for you, 2 by 2. Yeah. Cool. Calculus will never steer you wrong, might take a little while to get there. Geometry, if you got that kind of brain, okay, go with it. If not, go with calculus. Okay, ready for the new stuff?
No, that wasn't new. That
You could have
was.
done that. Well, we had to break it up into 2 zones. But we did one like that yesterday.
No, we didn't.
We did one where it crossed over, where a different top and a different bottom.
Yeah, we did. We never talked anything about a third equate. Those are completely different things.
Whatever.
Fine.
Complainy pants.
What am I?
Complainy pants.
My pants cannot complain, only I can complain.
I'm personifying your pants. Here's your zone. Boom. Okay, so the region that is enclosed by those 2 entities. Okay? What do you want to do?
See where they equal each other.
See where they equal each other? Okay.
Would these be non-calculated, I think?
Oh, absolutely.
I was like, it makes sense in relation.
However, if it is a calculator, you do everything the same way you just did, except plug it in when you get to the integral part. Now, I will say, this is gonna be one of your 6 free response questions, the whole area and volume, which we're gonna cover next. That will probably be question number 1 on the AP, on the free response AP. 90% of the time it's question number 1. If it's not question number 1, it's question number 5. So you can expect it. If it's question number 1, that means it's calculator, which means they don't have to make the intersection points pretty, okay? Do you know how to find intersection points on your calculator? Where you graph?
Intersection.
Right, okay, so that, as long as you can do that,
It's always
then
like,
you can
this
do,
would, should.
make it easy, all right? So what they would be testing then is to make sure you know how to set the problem up, not necessarily how to find that intersection point, which is honestly probably worth only 1 point. It's, do you know which function goes on top and bottom? Do you know if they cross over, stuff like that. And you would not get any work for the algebra because they expect you to type it in your calculator. Antiderivative from A to 7.325, blah, 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 okay? Let's see here. Oh, you want to find out where they meet? Got it. How do you want to do that?
Oh, so we equals
Okie dokie.
Probably.
What?
Guess we want this, make that square root of x.
That's easy enough. Okay, so if we were to think of this as what?
Y equals square root of x.
That's one of our, things.
It is a parent function, the square root, yeah, it is a parent function. So if we set these two equal to each other, intersection,
Um, X minus
0.4 points.
two. Ooh, wait a second.
So where does the square root of x equal x minus 2?
Wait. If I know anything about graphing, that's that there's no bound part. Because if it's, y equals square root of x is a curve that never goes to zero, and then it starts under, x starts under zero, so there's no actual bound part.
Okay,
And they don't explain it, what's bound, so.
good eye. However, this is bounded.
Oh,
You just got do me a favor, and we'll get to yours, if you didn't hear that. He's talking about how this right here, if you know the graph of it, the square root of x, and this line, which is below the x-axis, if you draw those two things, there's not a closed region, or so Michael claims.
Always that one.
No, you know what? I'll give you mad props for the statement you made, that that graph and that graph, when you graph them, do not have a bounded region. However, this problem does describe a bounded region. Help me figure out what this intersection point is. It's all for x.
Move x to the other side.
What's that?
Square.
Square both sides, yeah.
Yeah.
Most mongoloids are just gonna call that x squared minus 4, or even x squared plus 4, so retarded. This is x is equal to x squared minus 4x plus 4. Bring the x over, x squared minus 5x plus 4 equals 0. That factors into negative 1 and negative, excuse me, minus 4. Cool? Not cool. Plug those back in. What's the square root of 1?
1.
Good. 1. What is 1 minus 2?
Negative 1.
What's the square root of 4?
2.
2. What is 4 minus 2?
0.
Wait, 4 minus
4 minus
2, 2. That one
So
works.
1 doesn't work, but 4 is. So x equals 4?
Yeah, kinda.
Intersects at 4, which.
Are you just have plus minus square root of x?
That's actually two pieces of the same problem. It is plus minus x.
Oh. Yeah.
Thanks, Michael.
Yeah.
What did I do? You didn't
You
say
did that.
You didn't say anything to
So
stop
we
me.
actually
did that.
have
You didn't stop me.
3 functions here, not just 2. By the way, that's not a function, but when you do this, you can rewrite it as 2 other functions, okay? Why don't we take a moment to graph this, just to see what's really going on. By the way, this works in the bottom half.
Yeah.
So that 1 will meet the bottom half of the graph at -1, okay? Look at it graphically. We have, okay, so let's see here. We've got this square root, which does like this, and the negative square root, which looks like this. Nobody recognize that as a sideways parabola?
Nice.
Okay. Then you have x minus 2, so it cuts through like this. And lo and behold, we have
I think
a bounded region.
didn't.
Okay. This point right here where they intersect is the point 1, -1. And it is this line with the bottom half of that. This point of intersection is the point 4, 2, which is this line with the top half of the parabola. So we're talking about that zone right there. All right, everybody go with that?
And then top is always gonna be the plus square root of x.
Good.
And then the two bottoms will be the minus square root of x. That stops from the interval of 0 to 1.
Good.
And then x minus 2 from 1 to 2.
Very good. So if we set this up into two intervals,
So there's one.
we'll have zone number 1 going from, maybe I should put
John's
this here.
definitely not drawing the scale.
It's not bad.
One's there and two's over there.
2's right here. 4 is right here.
Oh,
It's not as bad.
he
Okay.
can't read graph.
It's not.
Alright, first zone is gonna go from 0 to 1. We're gonna have the positive root of x on top and the negative root of x on the bottom. Okay, clean that up a little bit. The positive root of x on top, negative root of x on the bottom. No big whoop. Plus, second interval will go from 1 to 4. That's where we're stopping over here. Top is still gonna be root of x. Bottom is going to be our line x minus 2. Okay, let's rock and roll. I would clean it up just a little bit. We got from 0 to 1, this is gonna be 2 roots of x, dx. This one, you really can't do much cleanup on it. You've got root of x minus x plus 2. That's about as good as I can make it. All right, number 1. Okay, that's x to the 1/2. Raise the power 1, we're gonna get x to the 3/2. Then we're gonna multiply this by the reciprocal 2/3, and 2/3 with that 2 is gonna give us a 4/3. And we will, let me do that, we will evaluate that from 0 to 1. Second one, okay, that's gonna be 2/3 x to the 3/2 minus 1/2 x squared plus 2x, going from 1 to 4. All right, thanks calculus. Talk to you later. Stick in 1, we're gonna get 4/3. Stick in 0, we're gonna get 0. Man, do I love 0. Love 0. Plus, okay, 4. This is really not that bad. Square root of 4 is 2. 2 cubed is 8. 8 times 2 is 16, so 16/3. Stick in 4, we get 16 divided by 2 is minus 8. Stick in 4, woo, look at that. Love that. Minus, stick in 1, we're going to get 2/3 minus 1/2 plus 2. Okay, let's try not to mess up our arithmetic. These two 8's cancel out. That was convenient.
18/3.
Okay, I think all of our thirds together, we get, 18/3. You have 4 here, 16 here makes 20, and then minus 2 makes 18/3, which is 6. So that takes care of all of you, and you. That's a minus 2, and that's a plus 1/2. So we get 4.5 or 9/2. Cool. All of our area was 9/2, 4.5. Okay, I did mention that this one had a little something extra to it. A little something to it. This is a trick that not a lot of people use, and I don't know why, because it is fantastic. Why did we have to split this? Why did we have to set up two integrals?
The y is squared.
Not because the y was squared, per
Is
se.
it positive or negative? Wait, there's two intersections.
Because there's two different zones. When we look at top, bottom, which one is top, which one is bottom, there were two different possibilities. one region had this on top, this on bottom, and then another region had a different set of top bottom. We can set this one up with only one integral, one. But we have to redefine what we consider top and bottom. All right, everybody take your heads and turn them, tilt them to the
It's-
right.
We can consider the function of.
If you were to tilt your
Like you
head
said,
to the
you see
right,
it as a sideways cracker one.
this would be the top,
That's
and
fine.
this would be the bottom. So if we rethink our mindset, instead of thinking x's, if we think y's, then this is top and this is bottom.
Then you only
So-
have to do one.
When they say x equals y or y plus, just think of them both as variables. One, either of them can be your y, either of them can be your x.
Correct.
And
So if I want to try this one with a y approach,
so
okay?
make your y your variable and your x dependent.
Correct. Correct. So think of our y as our variable, which means y applies to everything. All right. Let's do this first. If we're going to go with a y approach, which function is on top?
The function, the y squared.
Look again.
Which function is it?
Oh,
The line.
which one?
The line
Oh,
would be
okay,
on
this
top.
way.
Okay.
No, which one? This one, not this way.
You think positive, negative. Here, this is positive y values, negative y values, so we think top, bottom. Here, positive x values, negative x values, top,
Yeah, okay.
bottom, okay? So to me, the top function is gonna be the line. Tiny, tiny problem with thinking of the line, though. Actually, thinking of the line is good, tiny problem with it. I can't write x minus 2, because this whole problem is supposed to be in terms of y.
So
Well, that's
then
an easy
it's
fix.
1 plus 2.
Good. So that's what I'll plug in as y plus 2 instead of the x minus 2. So top function is going to be y plus 2 minus bottom function, which they have already
Y.
conveniently given to me, which is y squared.
Wait, no.
Yeah. Convenient.
Yeah. Okay, notice dy. And now you understand why I harp so much about your dy's, dx's, dt's. It does matter what you put here because it refers to the variable in the problem. One other thing, starting and stopping.
Oh,
You have to do this.
yeah, so it'd be -1 to 2.
Very good. For my y values, my y's are going from -1 to 2. In the same way that we let our x's go from 0 to 1 and 1 to 4, this problem we're going to use y equivalents, so we're going to go from -1 to 2. Okay, let's do the math. Don't really need to doctor that any, it's pretty good. 1/2 y squared plus 2y minus 1/3 y cubed from -1 to 2. Excuse me. Okay, if we stick in 2, or have that as 2 plus 4 minus 1/3. No, not 1/3, what's wrong with me? 8/3. I think that's right. Okay, minus, stick in -1, we get 1/2. Stick in -1, we get -2. Stick in -1, we get positive 1/3. Okay, let's do some whole numbers here. 2 plus 4 is 6. 6 plus 2 is 8. Okay, this is a -8/3, and this is a -1/3, so -9/3 or -3, and that leaves us with a -1/2.
Stupid.
Okay, 8 minus 3 is 5, 5 minus 1/2 is 4.5, which is 9/2.
Yeah, we did.
Should we have gotten the same answer?
Of course.
Same area, hasn't changed.
We just rotated it.
That is a very, very neat trick, especially if the other variable works out nicer. And when I look at this one, you know, yeah, it was fine, we did it fine this way, okay?
Square root's not nice.
Yeah, I can deal with them, I can do it, whatever.
compared to.
But if you reevaluate the way you approach the problem, think about, and by the way, they're not functions, but when we turn our head sideways, we treat them like functions. You know, this is top, this is bottom, kind of thing. When we only have one top, one bottom, this is a very, very nice alternative, okay? Sometimes on the AP, they don't give you an option. They're gonna give you pictures where you have to go with Y. Unless you wanna make 6 or 7 different regions and then add all of them together instead of just the one region of Y. But good luck with that. All right, ladies and gentlemen, there is the culmination of area between curves. Tomorrow, we're going to look at something called average value of a function, and then after that, we're gonna spend a good week, week and a half on volume.
Question.
Volume is awesome.
So when they give us an integral from like 0 to something or whatever it is, that pretty much makes our x could be, it's different if you use
Correct.
y. So
Right.
at that point, you have to assume.
Yeah, at that point, when they say, okay, let's bound it by the line x equals 1 and x equals 5, they're basically telling you, use x's, start at 1, end at 5. The only trick to those kind of problems is whether or not your function's crossed over somewhere in the middle. That's the only thing you would need to worry about. Okay, now, at this point, we have we got a good deal of time, about an hour. I imagine y'all are gonna take lunch today, probably. I would suggest on this one, do a couple of homework problems if you feel like you need it. Great day for quest time, if y'all wanna use each other, because these quest questions are not exactly the easiest, and they are due Friday. Come hell or high water, you will give them to me on Friday, period, okay? So, the rest of the time is yours to use as you see fit. So
Oh,
we
dang,
can
that
go
was
ahead
the
and
lesson?
turn that off, yeah.
Just pushing y's and x's is the lesson. I like it was awesome. I like the other one better.